Welcome back to the Georgia Tech Metropolitan Opera, where we will be singing about computer vision for the rest of the day because I am like going nuts already recording all these lectures and I have to do something differently. However, as my children will tell you, my singing about anything is generally a bad idea. So let's chat instead. So last time we were talking about motion. This is within this general context, and we talked about that if you're looking locally, you can't actually tell the direction of motion of a pixel. And that was referred to as this aperture problem. Remember this little demo where we said that even though the actual thing is moving sideways and down a little bit, you see it as moving upwards because the only part that you can see, that edge, all you can tell is the direction of motion in the direction of the gradient. And we showed that here that that was derived from our brightness constraint equations, where we showed that the UV dotted with the gradient has to be the negative of IT. That's what that equation says. But any UV, any motion whose component perpendicular to the edge along the gradient is the same would be an acceptable UV. So we needed some additional constraints. So last time we talked about introducing some global requirement. We talked about a smoothness constraint that would allow us to optimize a solution over the entire image. But today we're going to look at more local and frankly much more effective or certainly more commonly used methods.